Today on ENR's Critical Path podcast, we talk to two authors of a Transportation Research Board report that develop guidelines for state DOTs to conduct element-level data collection on bridges using unmanned aerial systems, or UAS. I'm Eileen Cho.
And I'm Jeff Yoders.
Welcome to a very special ENR Critical Path podcast, which is both transporting tales and a tech talk, and our first ever video podcast.
Hi, everyone at home.
Hello. Our guests today are Alicia McConnell and John Zuleger. Alicia McConnell brings over 15 years of transportation and technology experience to Rawlins Infra Consult. She began her career as a civil engineering designer, working on large roadway projects in both Wisconsin and Illinois. In 2018, an interest in technology led to her involvement in UAS and to investigate how these tools could be applied to improve transportation project workflows. She has developed and led UAS programs ever since, including oversight of a nationwide network of pilots that perform surveying and mapping, bridge inspections, construction inspection and monitoring, disaster assessments, roof inspections, and thermal analysis. She is a certified Part 107 UAS pilot. Her work with NCHRP to develop AASHTO guidelines for UAS applications for element-level bridge inspections is ongoing.
John Zuleger is an advisor to Rawlins Infra Consult, bringing experience in structural engineering design, rope access, UAS bridge inspection applications, and asset management. Notable projects include ABC bridge slides, the Leo Frigo bridge post-collapse analysis, and the Brent Spence and Hernando de Soto bridge emergencies. He is an SPRAT Level 3 climber. He incorporated UAS into his inspection team starting in 2016 and became a Part 107 certified UAS pilot in 2018. He develops next-generation tools for asset management with advanced predictive and prioritization modeling, including enhanced 3D modeling and digital twin integration. Welcome, John.
Yeah, thanks.
Welcome, Alicia. Welcome, both of you.
Thank you.
Thank you.
Alicia, you were featured, I can't believe it's been 6 years ago, on the cover of ENR, a story that I wrote about how drones were starting to become part of the bridge inspection process. And I guess what we need to talk about is what's happened in those 6 years.
Wow, what hasn't happened?
What hasn't happened?
That was a really, really long time ago. And actually, for full circle, John took that picture. And that particular photo was the second bridge inspection that I had done. The first was a project for Wisconsin DOT where we did 3 separate structures, just testing the technology. And it was with the only drone at the time that had upward looking capabilities. So 180 degrees of view. Now that is standard in industry inspection, drones that are available across the, commercial available off the shelf. So since then, so many things have changed. John, that was the first inspection that he brought UAS and drone usage onto because some of the scheduling had gotten delayed. There were high winds, and we just needed to be able to access some of the elements in, call it an easier, more efficient fashion. So we went out, did that inspection. John captured that picture, and that was it. And I like to look back at this and really think about how far we've come, how far the industry has come, and how far technology has come as well. This is one of our, I'd say it was the second UAS that we purchased as a company at that point. It had dual operator capabilities. A lot of them are kind of single operator now, but it reduces the workflow for the pilot. You can have an inspector operating the camera. So it's been quite a journey. We've had hundreds of inspections since this time. And this is actually, the start of the journey that led John and I into being selected as part of a larger team to do that NCHRP research report.
Mm-hmm.
Yeah, as a technology reporter, I often say this, UAS drones, they've reached ubiquity. It really is amazing how fast that's happened. There's a lot of other construction technologies. If you look at BIM, that's been like a 20-year journey, but it was really fast how quickly the industry adopted UAS drones and used them for these very useful cases such as bridge inspections, right?
Mm-hmm. And we saw the benefits almost immediately on this inspection. Like Alicia said, it was springtime, there were high winds. Going rope access down those cables was supposed to take half an hour. We were getting up to an hour and a half, 2 hours. Our, team members were fatiguing. And so we, kind of stepped back and looked at, what data are we getting out of the UAS and said, this is comprehensive enough. And we came back like a week or two later when we had better weather, and it was greatly more efficient. And the data we got out of it was exactly what we needed.
When were you guys asked to author this report for the Transportation Research Board, and how long did it take? I know it's ongoing, but this is the initial report that I saw.
Yeah, so we were selected, I believe it was May of 2021, and really got going around June of 2021. So at that point, we had, like I had mentioned before, this was really the first project at John's initiative to start tracking the benefits of utilizing this technology as an access method for inspections. So we had repeat inspections every other year, and we would track, it was almost like the divide and conquer sort of method. All right, what visual inspection can the drone team perform that can offset the workload for the rope access, lift, other inspectors out on site. So leading up to that, we had multiple other projects, a project for Pennsylvania DOT, a couple of other DOTs where we had assisted with their bridge inspection programs, processes, and methodology around the data collection and use of drones all day operation. So battery management, everything that goes into being self-sustainable out on a site that may be in the middle of nowhere. So that's where the project really started. It starts with identifying knowledge gaps, literature reviews, and then after 6 months, we had a report due, and then had a year of research, which is where the bulk of the work, I will say, was done. We had to choose per the guidelines or per the scope of work, we had to choose 20 structures in 4 different states and identify as many structural elements as we could and access methods with the UAS to perform those inspections. So really we came up with our methodology, determined, methodology based on our own experience, and then went out and actually tested it, like following these exact procedures. What works, what doesn't, where did some of the procedures, or where could they be improved? And John, I don't know if you have a picture of us out on some of these sites. We ended up choosing 22 structure types, and I believe it was 11 different actual bridges, but different geometries, different structures, different elements. Here you see here we are performing a calibration, which is one of the steps in the methodology. But if you can imagine, as an inspector, you kind of calibrate your own view whenever you're out on site to see, like, hey, I need to see a crack that is a millimeter wide. Yeah, and that's part of the process there, because the drone doesn't do the inspection, the inspector does it. But you have to make sure that the tools you are using are compatible with the inspector's capabilities. So, John, is there anything you wanted to add to that?
Ooh.
Yeah, and you can see the range of like the types of bridges we're looking at. So, as we got into the research, we really had to think about, okay, the elements across the country, I think it's 617,000 bridges that are inspected every other year, the different programs that they're on for 2-year cycles, depending on, the type of structure. But we saw a lot of multi-girder type systems. And that was really important for us to investigate. You have these beautiful historic bridges, like that one in Cincinnati, but then you also have just the everyday highway bridge, right? Like these multi-girders here. So we had to think about, are we capturing the right elements to show folks how to, navigate these between the different elements to capture the deficiencies. And here you can see like a large crack in the girder. We wanted to make sure, like Alicia said, it's not the drone detecting it, it's the inspector. And so on these various platforms, whether it was our kind of, as we defined form factor 1 and form factor 2, the smaller and larger UAS, are they capable of getting to where you need to be able to see these things? Because some of them can't get all the way up in there. So yeah, this really helped us, dial in where we wanted to go with the research.
Yeah, and the first one you showed there was, I think that was in Milwaukee, that cable stayed one is, you've got to check the connections of the cables, right?
like up in here.
Yeah.
Yeah, I mean, like you have across this, I mean, all the different cable types, braided steel cables, like on this one, when we did some cable stays, let me pull this video up here, if it'll play. And this one here, you have those cables like we were rappelling before. You have the sheaths out in there. Alicia, I think it was our first inspection with this, right? That you guys came back after the first cable and came running down and said, "Hey, we've got something." And there's a big crack in one of the
Hmm.
cables. There was something leaking out of it. We had one of our inspectors actually rappel down and give it the lick test, and he's a special inspector. But it turned out to be the grease from inside the cable, not rust. Very scientific process. But essentially, it allowed us to detect out of 96 cables one major deficiency, and so
Hmm.
that really reduced our personnel at risk hours. And those were those case studies that helped us build towards the research, build towards the guidelines and implementation, and really unlock, especially from the drone program side, what was in Alicia's head from all the things that went right, and then where we needed to improve, and a lot of lessons learned came out of that to then build into the guidelines and research.
Now, were both of you have worked on inspections of sort of after bridges had to be closed because of some deficiency, like the DeSoto Bridge or Brent Spence. Were drones deployed in those sorts of inspections?
Absolutely. And, we oftentimes talk about drones as a tool in the toolbox because
Hmm.
as part of an access method, there's binoculars, there's ladders, there's hammers, there's all the tools that an inspector uses. A drone is another one of those. While its capabilities are far exceed some of those in some situations, um, those access methods in emergencies like that are limited. So whenever you cannot get on the bridge because of personnel safety, the drone becomes that method to view what you need to do. You can't get hands on at that point, but boy, with a great drone and a great camera, you can get very, very close. The picture you see on the screen there is one. I don't know if John took this one, he may have, but you can see on my screen, we have a live feed and we are looking at a crack as an inspector is performing an inspection right there. And
Wow.
he is reporting back to the team that was doing the starting on the repair work, the design for the repair. And he has, you can see up his phone. So he has an earpiece in, he can hear the questions. We are
Hmm.
following him with the drone. He's pointing to things and saying, what about this? What about the torsion on the structure? What about this? What about,
Mm.
what are the measurements that you specifically need to start your design? Instead of sending them a report, they comment on the report, say, we need you to go back out and do this. We did this in the span of 4 hours. So that was a
Faster.
fantastic use case there. And, you can see us in a mobile command vehicle there, and we are actually looking through the data live and, making sure that we had everything we needed, but also kind of expanding our range to make sure
Hmm.
there weren't other major deficiencies out there. If the bridge is going to be closed, we might as well fix anything else, knowing what we know. And yeah, going from there. John, anything to add?
Yeah, I think in the span of a couple hours, we recognized just how important the drone was to an emergency situation. It allowed us access where otherwise, we may not have understood. Is it still growing? You look at the crack from the underside again. I'll go back to that. We didn't quite know yet. Was it safe to put somebody out there? We didn't have the engineering to tell us, could we put vehicles out there? So all those things became, unavailable to us very quickly. And, this was like one of the pictures I was sent while we were on top of the bridge. And
Mm.
it was, oh man, we've got to get everybody down and we've got to get everybody safe and the public safe, shut this thing down. And then after that, it's monitoring. And that's where the drone really helped us be effective in making decisions throughout this process.
Yeah,
And
John, your skills that I went through there, the repelling and everything else, those are still very useful and necessary, right? This is just essentially a
A tool.
safety augmentation. Yeah.
Oh, absolutely. Let me bring up one of the pictures here. I mean, you can see when we would deploy rope access teams, you had several inspectors on rope. There's, still several fatigue-prone details across a type of structure like this. work checking the nooks and crannies, and the drone can, get some of the global elements, right, and really help us kind of maybe dial in our inspection or pick up some of the things like here, the cables, right? There's certain criteria for the elements when you're inspecting them, that's either federally or state mandated, but where applicable, something like these cables, the drone can really help pick that up and save us from having to rappel the full length. But we're still down into those gusset plates and, like I said, the nooks and crannies of it, getting into the hands-on portion where we really need to focus our inspectors' attention.
It seems that there was a bit of a balance to be struck between one drone that was sturdier and therefore less vulnerable to high winds and such. But then there was the more agile drone that could do, more intimate inspections. Is this a trade-off that can change over time?
Yes and no. So as you mentioned earlier, with some of the, talking about the technology changing,
Hmm.
one thing we wanted to do with this research is make it a little bit technology agnostic or drone agnostic, where that's where we decided to choose those different form factors. So what you see on the screen here is form factor one, and the parameters for form factor one are typically the sensor is not interchangeable. It's something that can be carried almost in like, it's like your purse-sized drone.
Mm.
Um, can fit within tight spaces, oftentimes has high obstacle avoidance capabilities. And that differs from form factor two in that form factor two is typically something much more robust. It has a higher max wind resistance. So when you think about max wind resistance, it's if the wind was gusting 30 miles an hour, can my drone fly 30 miles an hour to combat that and come back to me if I need it to? So in these situations, you get channelized wind gusts, you get eddies coming off the bridge, and you really need a stable platform. Every drone varies in its max wind resistance, its stability, its obstacle avoidance. However, you can kind of generalize some of these into, like I said, the form factor one and form factor two, where it does have oftentimes dual operator capabilities, interchangeable sensors. You can have additional attachments to it, maybe a camera on the top, really things like that that make it more suitable to kind of like exterior versus interior. So getting up in between the girders, having something large isn't necessarily conducive to a great inspection, whereas something small with high obstacle avoidance, it just travels, very quickly. John, I don't know if you have the steel tubs picture, if you want to
Yeah, let me
look for
pull that
that.
up.
That was a great opportunity for utilizing something that has good obstacle avoidance. And no matter what drone you have, slender members always pose an issue because of the detection of that obstacle avoidance. So it's really learning, learning your equipment and understanding the limitations of it, but
Hmm.
using it within those limitations to the best of its ability. Yeah, there
And
you go.
Mhm.
some of these
Wow.
shots are like they're FPV drones, or what you see is what you get. You see what the drone sees, and other ones you're sort of following. It seems like there's two of them. You're following another one around, either from the ground or from another UAS.
Yeah, so we did that as a what we're hoping that may get included in the final AASHTO guidelines.
Hmm.
I think we kind of veered off of that topic, but after our, yes, this is the one I was looking for, John. Thank you. Our research and reports have been completed, and we are waiting on publication for AASHTO. It's in the queue, so we're hoping publication happens either late this year or early next year, just for good timing. And that's the AASHTO guidelines. The report is out, NCHRP report
Hmm.
1114, but that will then segue into the AASHTO guidelines, which include all of these inspection type procedures. But yes, so to answer your question, one of the things that we thought would be valuable to end users is we can describe a method for accessing an element with words, but some people are visual learners. So we did a little bit of this data collection of the data collection to help an inspector see whenever I talk about getting above the bottom flange and stabilizing the drone to progress through a curved girder in this situation,
Mm-hmm.
seeing it, words or a picture is worth 1,000 words. A video is worth probably more than 1,000
pictures.
words. Yeah.
Right.
Yep.
And here, so we tried to include some of those access methods to show how we were actually accomplishing that access method.
Wow. Are you able to give us a little preview of those guidelines that will eventually be made
So that
available?
the document itself, I cannot, but what I can share is what is included in those guidelines.
Okay.
Yeah. So in here, let me pull that up. So in the first part of the guidelines in chapter 1, it's obviously a lead-in, an introduction to share how the guidelines should be used. And we tried to structure it so different levels of an organization or a bridge manager would be able to utilize these. So if you have a bridge inspection program, maybe the leader of that program isn't boots on the ground doing inspections, but they're organizing those inspections. So what role does that play? So there's some organizational structure that we have provided there to have some peer review, some inspector oversight, and just to make sure that the inspections are being performed consistently, but also all the data is being collected that needs to be collected. The entire bridge may not be able to be collected with a drone. So how are you making sure your inspections are comprehensive using a drone and the inspector's boots on the ground capabilities? So that's chapter 2. Chapter 3, we have UAS selection considerations. So it's really a flow chart that brings into consideration some of the NDAA compliance. NDAA compliance is National Defense Authorization Act, and some states are adopting that NDAA compliance, meaning foreign countries that may pose a threat to the United States that have software or hardware in those drones are not allowed to be used to collect data from some of our nation's critical infrastructure. So if that state has that initiative, then choose the drone that has NDAA compliance, and it kind of guides you through a process based on your needs, the inspection types that you'll be doing, and kind of inspector capabilities too. Then we move into personnel training recommendations. And this was something that I would say, took the initiative to add in simply because whenever you take your Part 107 exam to become a remote pilot, there is no training required. You have to have the knowledge base, but the skills are not required. So you can have somebody come in, an inspector come in that says, yes, I'm ready to fly, but they don't have, you haven't tested their dexterity or shown them any method to use that tool to perform the inspection. So in that chapter, we put in recommendations for minimum training requirements, put in some maneuvers that we use to train our own pilots. And I was fortunate enough to have a chief pilot that had incredible skills, and we developed that training material together. And some of the movements, dual inputs on the controller to accomplish, let's say you need to do a half moon around a bearing to make sure you get complete coverage of it. How do you accomplish that? So some of those training recommendations, some practicing, some maneuvers for the pilots to practice, and it will correlate back to actually another NCHRP report that's going on right now, which is basic pilot proficiency. So we ended up actually pulling some of
these drones aren't cheap, right? You don't want to.
No, they aren't. So, the familiarity with the equipment is obviously very important, and that's noted in there too. And then chapter 5, we've got our UAS bridge inspection methodology, and that's where John really, really helped. We've got, hours under our belt of how to access the different elements. John, do you want to talk about chapter 5?
Yeah, and really at the core of a lot of this, implementation is going to be, really important. So, how do you actually fly around these elements? It's a combination of pilot comfort. It's a combination of the characteristics of the aircraft. What is it capable of from detect and avoid? It's camera sensors, things like that. So we try to build all those components into an easy read. Like, I'm inspecting a cable stay, so I need to do these things. Probably using this aircraft, right? That's kind of where we wanted to make it as simple as possible, Most inspectors are familiar with the bridge types and everything out there, but what are my standoff distances that I can detect, the actual deficiencies, small cracks and things like that. We wanted to highlight that for them and kind of give a framework of where they could just say, okay, I'm inspecting a girder bridge today. I'll jump to that part of the guidelines and see what I need to do. So that was kind of the intent of where we wanted to go with that. And then really, it comes with practical hands-on training as well from experienced pilots that can kind of help guide you in the field. I wouldn't go out if I've been flying girder bridges all my career and had to go fly a large complex cable stay. I'd want somebody to kind of show me how to, go through that for the first time. So, it comes with the practical implementation side of it as well.
Yeah, I've watched a few of these inspections, and like you were saying, you have to get in between the girders. There are situations where there's like electrical cables and things you need to inspect, and being able to get that camera on a very tight place it's a skill you have to develop as a pilot, right?
Oh, absolutely. And, you'll get a lot of pilots who come out and like Alicia said, they've been flying for years and maybe they've been flying drone racing league, right? And it's like, we are the exact opposite. We are exploring and look at philosophy, maybe in bridge inspection versus, some of the other activities that drones are used in, and even in the transportation industry where they are really valuable for construction monitoring or tower inspections. It's just a different flight operation. And I think, Alicia's done a great job of, explaining from the data, data collection to data management, what you need to be looking for out there. And I'll never forget a second backup hard drive to make sure, data gets really expensive, after a week of inspecting. So
always have a backup.
Well, and God forbid you lose, someone hits the UAS into the side of the bridge and it's gone.
So
It happens.
That's one of those exact scenarios where I recommend like pull the data off the card after each flight. And that's to round out our chapters, that is chapter 6, some of the data storage, because out on a major large complex bridge inspection, we may pull 200 gigs of data. If you create a modeling flight, or you do a modeling flight in addition to some of that manual flying for inspection, then you're looking at possibly double that. There are huge data sets here. But in some of the processes that we have laid out, we also included checklists. So a pre-flight checklist, flight request forms, the selection flow chart, some of the FAA regulations that are pertain directly to bridge inspection type flights. But one of the part of our recommendations in the methodology is pull that data off the card after every flight, because after 8 hours of flying, if you have 65 gigs of data from that day and your drone decides to take a drink, you have lost. It's not just the drone, and that's expensive enough,
right.
But you have lost all those labor hours. You've lost a day, you've lost time. So John says that in jest, but I am yes. And that again, that
Absolutely.
was a chief pilot that recommended that to me. And then after we had it happen one time, I became more of a stickler on it.
Skydio's not making them cheaper,
No one is.
So what do you see happening in the next 6 years, you guys?
I'll start with this one. So there are a lot of, these guidelines are a great first step. But what we focused on in this research was really, I'll say, the manual application of drones for data collection. So if an inspector is going out to do a data collection or do an inspection, how can they use this as a tool? Part of our research was understanding the capabilities of AI for automated defect detection. That was a very small sliver of this because AI detection is sensor agnostic. So I could use my iPhone. Somebody could go out there with a video camera. We could use a drone. So that felt like it was an area for further research that could apply to drone technology, but maybe we shouldn't spend our time really investigating. Additionally, some of the modeling capabilities. The way we kind of looked at that during the research was, you create a model of a bridge and you can inspect some components of that physical model. However, depending on how some of those, the photogrammetry meshes and that, it may or may not be a good representative model for that snapshot in time. We do think that it is a supplement and it can be used for some of the asset management components of it. So, the modeling is becoming more and more, and it's tying in with BIM, and there are so many things that you can do with this data. I really see out in the future that this bridge inspection data, while it may start as a static model, it really gets pulled into some of the asset management and helps with some of the decision making that owners can do based on maybe an AI application of defect detection.
All of that data, you're right, it's very rich, and processing it, becomes the next big task, right?
Yeah, absolutely. And that's where some of the data storage comes in. And what do you do with those models? Because right now the inspection report is what's federally required. So if you create a model and you have a model that is acting as an asset management tool, identifying those defects, being able to track those defects over time, it's valuable to an owner, but not being federally required. Maybe some DOTs aren't, or some bridge owners may not be interested in that outlay of cash to create those models.
Right.
And I think you should be selective too. Some of the larger complex structures, maybe. Do you need a 20-foot structure over, that's a culvert over a creek? Probably not. So, using some logic and good decision making. John, did you want to add anything on how models may be used in the future, asset management, drone data, any of those topics?
I think that's a big component where we've seen a lot of change, even in the last 5 to 6 years of doing the research, and now where we are as a profession and industry with drones being incorporated into our inspections. The modeling side is really valuable to me as an inspector and an engineer. Whether I'm, performing an inspection, looking at the model as a roadmap, I can show stakeholders, exactly what I'm looking for, and point them to the deficiencies when paired with the real-time imagery from the drone. That part of it's really beneficial. And then, if as an engineer, I'm performing a load rating and I want to see how things fit up, those types of geometries are really important. Maybe we don't have a plan set. All those components of a model can be really valuable moving this, kind of forward. And then, seeing where AI detection, AI flights, automation, and all this, I see a potential in that. We need to do it responsibly, I think. To Alicia's point, the inspector is the oh, did it cut out again?
No,
You're okay.
You're there.
And then, the inspector is the front line for all of this. They have to be able to detect and, make sure the inspection is being performed to the federal and state regulations. So we want to just make sure that, as they're using this technology, we're not missing something and say, yeah, the drone scanned everything, but, did it get above that bottom plan so you could see those welds and, things like that, where we're going to have critical areas for inspection.
Yeah.
Speaking of regulations, I seem to recall way back 6 years ago that there were restrictions on how and where you could use drones relative to a bridge. Like you couldn't fly it across like directly above, say, traffic or something. What has changed since then?
So I will say not a ton has changed in that area. So the
Okay.
regulations, when we first started, we were running off of it was a COA, Certificate of Authorization, for a Section 333 exemption, which was FAA's first take at essentially regulations around commercial UAS use. Then came Part 107, and Part 107 restricted flights over people, like unprotected people, non-participants, and moving traffic, and for good reason. And then they came out with, some of these, the 4 different categories, and it was, judging by the impact that the drone could have coming from, in flight if there was a failure. That didn't really take too well because it was based on kind of manufacturer guidance and manufacturer certification. So there's, and it's likely on purpose, but the responsible use of a drone out on a bridge inspection, transitioning over traffic. It's the way they state it, and don't quote me on this, but it's something like sustained flight over, it's like groups of people or congregations of people, something along those lines. So, if there's 6 lanes of interstate traffic moving at 60 miles an hour on average, an inspector should not be hovering over that in a situation where the drone could fail. Like if there's slender members, things like that, that's common sense. However, sometimes we have to get the data we have to get. So it wouldn't surprise me if people do that. So, thinking about the safe operation of those, you still are not allowed to have sustained flight over moving traffic or non-participating people, whether that's somebody on a boat on the river below or a pedestrian walking, just not flying directly over them. Again, it's common sense, but also public safety is first and foremost for an inspector out there, understanding what the risk is to the public when you have lane closures, people on the side of the road, drones flying overhead. So there are some rules that may be adjusted. They're talking, the FAA is talking about some of these adjustments, but there's also mitigations that you can put in place on the drones themselves. You can have prop protectors. You can have an audible warning if there is a failure. You can have a parachute. So there are a lot of those things that can help make that safer. And you could have a waiver for flight over people, but typically these inspections can, most of the time, 95% of it can be performed without putting the public at risk in those ways.
Yeah. You mentioned AI before, and I think there is great potential there, but structuring the data, that's what a lot of people are talking about right now, like taking all of these data from flights that have come in and structuring it properly to be, even have an AI trained on it. I think that's the point where there's a lot of hype right now, right?
Mm-hmm. Yeah, there's definitely, in the inspector world, I'll say that there's some fear, right? People are like, is this technology going to take my job? Oh, did it freeze again?
No, you're there.
There you go.
Okay, sorry. Sorry guys, I don't know why that driver is messing up. All right, am I back there?
Yeah,
Yep.
you're back.
Okay, all right. So, what was it? The AI?
Yeah.
Yeah, so in the bridge inspection world, there's, a bit of fear right now that is AI going to take my job? Is the drone going to replace me? And what we keep going back to is no, this is a tool just like your hammer, just like your ladder. It's really important to remember that this is just another thing to augment, a sophisticated line of tools within our inspector and engineering suite, right? And so AI, I think, has a lot of potential to help us recognize things. You look at like a parallel in the medical industry, right? You have X-rays that now have AI that can be flagged initially for the doctors, right? Same thing for inspectors and engineers here, where it might flag 80% of it, but then it gives us, insights as to, okay, where do I need to maybe focus my attention to say, hey, I see some efflorescence over here. Well, that might lead to cracking, or that is, because of cracking, spalling might be there. So I, start to dial that in. Hey, the AI didn't pick up exactly where it was, so now I can kind of draw that in manually myself. But I've also saved significant amount of time, scanning that on my own. So I think AI has some applicability there. It's just how do we responsibly use it as an industry and not just kind of let the black box take over and go from there.
Right. Well, a CAT scan or an MRI or an X-ray isn't doing the job of a doctor. It's just making the doctor's job easier, right? So feels
Exactly.
like this is
Great
similar.
analogy. Yes.
Well, I think we're just about at time, although I know between me, the transportation person, and Jeff, the technology person, we could talk to you two much longer. So we may simply just have to have you back.
We'd love that. And you can tell we'd love the conversation as well.
This has been another ENR Critical Path podcast. I'm Eileen Cho.
And I'm Jeff Yoders. For more podcasts, go to enr.com/podcasts or follow us on Apple Podcasts and Spotify.
Thanks for listening and watching. Bye.
Bye, everyone.